Hey everybody, it's Elisa. I'm back, and we're continuing to talk about the endocrine system. And this time we're going to talk about two components, the pineal gland and the thymus. So, the pineal gland is attached to the roof of the third ventricle beneath the posterior end of the corpus callosum. So, it's in the brain. After about the age of 7, it undergoes what we call involution, which is a fancy word for saying it shrinks on up. So it's primarily used early on in life. It is down by 75% by the end of puberty, and it is like pretty much barely even there, a tiny, shriveled, shrunken mass of tissue in adults. So we're struggling to understand all of the things that the pineal gland is responsible for or is contributing to, but we do know a few things. And number one is the pineal gland may influence the timing of puberty in humans. Um, it plays a critical role in timing of circadian rhythms, and it also helps synthesize melatonin at night. We know it has some roles in seasonal affective or the SAD disorder, which occurs in winter northern climates or just generally when there's not enough of that natural blue light um, to kind of affect our brain so that we understand the timings and can also properly calculate our circadian rhythm, right? And so that can also contribute to individuals who have too much screen time or lights on after dark. So that's like a thing. Some of these symptoms include depression, sleepiness, irritability, and good old-fashioned carbohydrate craving. So it's definitely something that seems to be possibly linked to the stresses and the conditions of the modern world, especially with artificial lights. Um, but there are some, just so you know, artificial lights that are used to combat seasonal affective disorder, and so I believe they mimic components of sunlight. Right. Okay, so 2 to 3 hours of exposure of bright light each day is going to help reduce the melatonin levels and kind of regulate out the sleepiness and the symptoms. We call that photo because of light phototherapy. And the thymus is also another one of the shrinking, disappearing glands. So it plays a role in three key systems, at least, that we're going to highlight. So endocrine, lymphatic, and immune system. So it is a bilobed gland and the mediastinum. So it's like kind of surrounding the top of the heart, essentially ish area. And so it goes into its shrinkage after puberty itself, which is good. And it's also a good reason to get those um, immunizations early on because it's the site of maturation of your T cells, which are important in immune defense, which generally your B cells are the target of these immunizations. You know, it's secreting hormones such as thymopoietin, thymosin, thymolin, and those are going to stimulate the development of other lymphatic organs. And so that's one of the things you need to think of, as well as the activity of the T lymphocytes. So here's some interesting little comparison here of the newborn versus the adult. Like in the newborn, it's like that sucker is practically has like lung or larger size, which is also a point for me to say that the lungs actually don't really fully develop until later into childhood, right? Because they're a relatively newish organ, evolutionary speaking. And then you can see the thymus later on in adulthood is much smaller, actually, much smaller, and it's um, kind of closed in, and in this rendering, it's actually changed color. But right, so that's just kind of something to kind of visualize. All right, and that's, I guess, it. That's all we are going to talk about for the thymus of um, right now. And so I hope that was helpful, and I hope you're out there somewhere having a great day. Bye.